In this video, I'm going to show you how to graph sine and cosine functions perfectly every time. Now, this is using transformations knowledge, and if you're interested, I made an entire video of transformations of parent functions, and I'll leave a link to that video in the description. Now, this video is timestamped, so if you want, you can just jump ahead to examples. But in the meantime, I think it's really important. A lot of people lack it's pretty much just algebra 1 skills by finding the 5 main x values when graphing the period of a sine or cosine function. And so it's pretty much just taking the average, so adding two numbers together and then dividing by 2 and just doing that multiple times. I just want to quickly add that this is just a snippet of my lesson. So in the description, I left a link to my website. You're more than welcome to download reference sheets, step-by-step answer keys to all the homework assignments, and a copy of this lesson. So let's pick on the sine parent function y equals sine of x. Let's say we want to find the 5 main x values, or the five critical values, whatever you want to call it, and it shifted to the right pi units. So there's that horizontal, aka phase shift. And now the period, instead of it being 2 pi, it is now 7 pi over 3. And 2 pi is the same thing as 6 pi over 3, right? So 7 pi over 3 is bigger. And so we see that it took a little bit longer for the function to complete one full cycle. And so that would imply that there's definitely going to be a horizontal stretch or compression, right? So, so let's look at the sine function, right? So instead of it starting at 0, 0, again, it has shifted to the right pi units. And so now instead of starting at 0, like I said, now it starts at pi. And because this is a sine function, one period looks like a sideways S, right? So if we were talking about a cosine function, it would look like that capital U. So the question becomes, what is this mystery endpoint here? So how can we use the phase shift and the period together? Well, keep in mind that the period, by definition, means how long does it take for a function to complete one full cycle. So we know that to be true. That's what the problem gave us, is 7 pi over 3. So let's just for 1 second take a look at the number line, right? Now, just a reminder, pi's, those are numbers. Pi is the same thing as 3.14, yada, yada, yada. So let's say we are on a number line, right? And I want to start at -2. Let's say I told you that we travel the distance of 3 units, right? So 1, 2, 3. Now we end up at 1. Now, algebraically, if we know that it traveled 3 units, right? So notice I'm trying to mimic like a period of a function. So algebraically, we can add -2 and 3 together, and we get 1, which was the correct answer. And so very similarly, how are we going to find that endpoint? If we know it traveled 7 pi over 3 units, we are going to add the phase shift plus the period together. Now, I did write a reference sheet, which I'll show you guys in a second, but just remember it's the phase shift plus the period. And we have beautiful algebra 1 skills. If you're taking this class, you are expected to have strong algebra 1 skills. And so don't worry, I chose an example that was very heavy in algebra 1. So this is really pi over 1, right? So pi is the same thing as 3 pi over 3, right? Because adding and subtracting fractions, we need common denominators. 3 pi plus 7 pi is going to be 10 pi. So we get 10 pi over 3. That's going to be our end point. And so now the question becomes, how do we find the other 3 main x values? So you're going to go in the following order. So I'm going to do the middle one together, and then I'll fast forward the other 2 just so you can see where the algebra comes from if you don't get the same answer. Now, keep in mind, this is a graphing video, so you could definitely skip to the later section where I start graphing sine and cosine functions. But in the meantime, so how do we figure out this middle, right? So we are finding on the number line the exact middle between pi and 10 pi over 3. How do we do that? We do that by finding the average. How do you find the average of 2 numbers? You're going to add those 2 n values and then divide by 2. So let's do that, right? So we're going to add pi and 10 pi over 3 together. And then we're going to divide it by 2. So again, those algebra 1 skills, pi is the same, pi is the same thing as 3 pi over 3. Now we have common denominators, so 3 pi plus 10 pi is 13 pi. So that's 13 pi over 3. And then divided by 2. A reminder, 2 is the same thing as 2 over 1. And so how do you do fraction inside a fraction? People know it as keep, change, flip, or people know it as multiplying by the reciprocal. So flip of 2 over 1 is 1 over 2. Last but not least, we multiply fractions straight across. So 13 pi times 1 is 13 pi. And then 3 times 2 is 6. So the exact middle is 13 pi over 6 in radians, right? And so now the next question becomes, well, what's that second important x value? Which, right, is the x value of that maximum point. And then we're trying to find the x value of the minimum point. Okay, so again, I'm going to hit the fast forward button. So I'm going to first find the x value of the second critical point. So what are we finding the exact middle of? We are finding the exact middle of those two n values, right? So those are the two that I'm going to add together and then divide by 2. And then how would I find that fourth critical point, right? So now I'm trying to find the exact middle on the number line of those two fractions. So I'm going to add those two together and divide by 2. Okay, so here are the 5 main x values. So again, I chose an example where it was algebra 1 heavy. So here it is. The start location of graphing is always going to be the phase shift, aka horizontal shift. Now that formula is you take the C value divided by the B value, and the end location, you're going to add the phase shift, so whatever that C over B value was, plus the period. And the period is 2 pi. Actually, it's supposed to be over the absolute value of B. But those formulas, I'll leave a link in the description. I did a whole transformations video as well as deriving those formulas. So take a look there. And what are we talking about in terms of A, B, C, D? A is the number. So again, I'll just pick on the sine, but it really could be cosine as well. A is a leading coefficient. B is the coefficient of the x term. C is that term added or subtracted inside the parentheses, and D is that value added or subtracted outside of the parentheses. So feel free to hit the pause button and write this down. I will be referring back to this. So first steps is we're going to analyze the equation. What we're going to need is the amplitude, the phase shift, the period, and the midline. That is it. That is all you need, only those 4 things in order to get started. So let's take a look at a cosine function, y equals 2 times cosine of 2x. So if you want, you can absolutely use this grid whenever you're taking a quiz or a test. I think it's people like the organization. It might be beneficial to write it in the equation a times cosine of bx minus c plus d. Right? So this is the same thing. So compare it to the cosine parent function. The a value went from 1 to 2, and then the b value also went from 1 to 2. Okay, so it's no surprise, instead of the amplitude being 1 in the parent function, the amplitude is the absolute value of a, and a is 2. So the absolute value just means it makes it positive. 2 is already a positive number. Okay, now what is the period? The period is, that formula is 2 pi divided by the absolute value of b, and b is 2. So 2 is already positive, right? So the absolute value of 2 is 2, and the 2's cancel out. So 2 pi divided by 2 is pi. So it completes one cosine complete cycle in pi radians, right? So instead of being 2 pi, now it's pi. So it happens in like half the time. Now the phase shift, that formula is C divided by B, and the C value is 0 and the B value is 2. So 0 divided by 2, well, 0 divided by anything is 0. So the phase shift, if I ask what the phase shift is, technically I should write none, right? So in other words, it did not shift horizontally left or right. Now, the phase shift is also always going to be the start value, always. Okay, and I do have a reference sheet in a second. So we're actually going to start at 0. Okay, and just really quickly, the midline equation is y equals d, and the d value, oops, I meant to write 0 here, and the d value is 0. So y equals 0 is the same thing as the x-axis. So this would be the midline. Okay, so now the last thing that we have to figure out is, what is this endpoint? So we know it's going to complete one full cycle in pi radians. So how are we going to use the phase shift and the period together? So the end value is always going to be the phase shift. So I'll do PS as phase shift plus the period. And if we remember when we were calculating the critical points in the previous example, we found that out. So the phase shift was 0 plus the period is pi. So 0 plus pi is pi. So that means that I can put pi somewhere over here. Okay, so that's going to be the start and the end. So we went over all the stuff in the box, the amplitude, phase shift, period, midline. We determined the start and end values. Now it's time to find, well, we already found 2 of the 5 critical points, so it's time to find the other 3. Okay, so how do we do that? So first we have to find the exact middle. And you could do that by taking the average. So you're doing 0 plus pi, which is pi, and then you cut that in half. So this is going to be pi over 2. And now how do you find the middle, the exact middle on the number line between 0 and pi over 2? So now you're finding the middle of those 2 guys, right? So you're going to add those 2 and then divide by 2. So 0 plus pi over 2 divided by 2. Well, 0 plus anything is itself. So 0 plus pi over 2 is pi over 2 divided by 2. So again, people know this as keep, change, flip, or this is like 2 over 1. So it's multiplying by the reciprocal, essentially. And in multiplying fractions, we multiply straight across. So 2 times 2 is 4. So this guy over here is going to be pi over 4. Okay, and then last but not least, we have to find the exact middle of between pi over 2 and pi. So those are the 2 we're going to add together and then divide by 2, right? We're finding the average. So pi over 2 plus pi, and then divided by 2. So first we need common denominators. So pi is the same thing as 2 pi over 2, right? So because you multiply top and bottom times 2. So now common denominator, so pi plus 2 pi is 3 pi. So that's 3 pi over 2 divided by 2. And we'll do keep, change, flip, right? This is over 1. And we multiply straight across. So 3 pi times 1 is 3 pi. And then 2 times 2 is 4. So 3 pi over 4 is going to be right here. Okay, so here are the 5 critical points. And so let's graph in the following order. Okay, so we already set up the graph with the critical points. Now, in my opinion, it would be easiest to first graph the midline, and then we're going to use the amplitude and the midline together to figure out the range. So the midline here, I did highlight in yellow here, and just a reminder that the amplitude was 2, so it goes up 2 units. And it's also the distance from the midline. So it's like essentially the midline plus the amplitude and the midline minus the amplitude. Okay, so last but not least, we're going to use our cosine graphing skills. Now, again, in the description, I left a link on what how the cosine and the sine parent functions look like. You can watch that video separately, but last but not least, we know it's going to be that U shape. So the cosine function always starts and ends at that maximum point, and halfway through, it's at the minimum point. So that means that, and at the second and fourth critical points, it's going to hit the midline. Okay, so it would in the end look something like this. Now, just as a checkpoint, so remember the amplitude is the distance from the midline to that max point. So the distance from there to there is 2 units. And the amplitude is also the distance between the midline and that in the minimum points. So it does check out. Those two distances are 2. All right, so next let's graph the sine function. So in other words, it's going to end up looking like a sideways S, but notice that the leading coefficient is negative. So we do know there's going to be a reflection over the midline. So instead of it going up to the maximum and then down to the minimum, it's going to be flipped. It's going to first go down to the minimum and then up to the maximum. Okay, so it's always beneficial to rewrite it in standard form. So the coefficient of X is 1. So just keep in mind, right? So the X is just in the parentheses, and then you're subtracting through. Okay, so that means that A is -2, B is 1, C is 0, and D is -3. Okay, so if it helps you, I would certainly write that down on the side, because that would help once you could just plug it right into the formulas, right? Okay, so the amplitude is the absolute value of A, and A is negative. So again, absolute value just means it makes it positive. Okay, so if it's already positive, it just stays positive. So the absolute value of -2 is 2. So here we have another example where the amplitude is 2, but now the midline is different, so the range is going to be definitely different. Okay, the period again is 2 pi divided by the absolute value of B. And so B is +1. And so 2 pi divided by 1, right? So the absolute value of 1 is just 1. So 2 pi divided by 1 is 2 pi. So it does complete one full cycle in 2 pi units. Now the phase shift is, did it shift horizontally left or right? So the phase shift is, that formula is C divided by B. And so remember that if we could just look over here really quickly, right? So C is 0 and B is 1. So 0 divided by 1 is 0. So it did not shift at all. So technically the answer to the phase shift question would be technically none. But it's nice to know that that value is 0, because as we said before, the phase shift is always going to be that start value. So again, we are starting at 0. And so now what is going to be the midline equation? So the midline equation, that formula is y equals d, and our d value was -3. So it's going to be y equals -3. So I would definitely, I could just highlight it in, let's do orange, so -1, 2, -3. So that midline is going to be right over here. So remember, we're going to add and subtract the amplitude from the midline to determine that final range. Okay, so the last thing we have to do is find that end value. So we know it starts at 0 and it completes it in 2 pi radians. So just using the formula, remember it's phase shift, which is 0, plus the period, which is 2 pi, right? So 0 plus 2 pi is 2 pi. Okay, so we know it's going to end at 2 pi radians. Now these are standard critical points. We already know that in the middle of those two endpoints is pi. Between 0 and pi is pi over 2. And between pi and 2 pi, we know it's 3 pi over 2. So that's the same one as the parent function. Okay, so since the amplitude was 1, so, right, this is at -3, I'm sorry, the amplitude was 2, we're going to add 2. So -3 plus 2, so we're at -1, and then -3 minus 2. So we're at -5, right? So the range is going to be between -5 and 1. And then last but not least, we're going to use the parent function of the sine. So again, usually it goes up to the max and then down to the min. The last thing really should be just make sure that if a is negative, that just means it's going to be a reflection over the midline. So a sine function always starts and ends at the midline, and then halfway through, it's also at the midline. Okay, so again, because the a value is less than 0, in other words, it's negative, it's going to first dip down to the minimum and then up to the maximum. So again, if the a value was positive, it would be the other way around, right? It would be like that. Okay, so in this third example, I got a little bit sneaky, so feel free to press pause and you can figure out what those a, b, c, d values are in this standard form equation here. The coefficient of the sine is really 1. The coefficient of the x is also 1. Now, let's see here. So it does say x plus pi. So since this says minus, technically speaking, right? So a negative plus a negative is a positive. So minus pi is the same thing as plus pi. And then the d value, so instead of I added it in the front, technically in standard form would be at the end. So the a value is 1, b is 1, c technically, right, if we look at, again, the standard form equation would be negative pi, and the d value is 1. Now, some teachers are really not that picky, so a lot of teachers might accept the c value to just be pi. I have a problem with that because that's going to involve the phase shift equation, which would influence your starting point of the critical values. But if you know from transformations, right, so the plus sign really means you're moving to the left. So as long as you are aware that your starting value is at negative pi, right? It starts at 0 for the parent function and it moves to the left pi units. So as long as you, again, are fine with that and your teacher's okay with you just writing positive pi, I don't have a problem with that. But again, right, since the phase shift is c over b, that really should end up being using the formula properly. Anyway, if that made any sense. All right, so now the amplitude, again, is the absolute value of a, and a is 1, so a is already positive, so the absolute value of 1 is 1. So you also have to ask yourself, when you do look at the a value, because a is positive, in other words, right, a is bigger than 0, so we already know it's going to be that standard sine function. In other words, it's going to go up to the maximum and then down to the minimum. If a was negative, that would mean it's going to go down to the minimum first and then up to the maximum. So again, that's something that you have to keep in mind when you do graph. Okay, so now the period is 2 pi divided by the positive value of b, so the absolute value of 1. 1 is already positive, so the absolute value of 1 is 1. 2 pi divided by 1 is 2 pi. So there was no horizontal dilation. In other words, there was no stretch or shrink. The period did stay the same. Now, again, the phase shift, that formula is c divided by b. So technically, the c value is negative pi, right, divided by the b value, which is 1. And negative pi divided by 1 is negative pi. So remember that the phase shift is always going to be the start value. So you will, right? So they always will match. Okay. But again, in transformations knowledge, if you're already aware that the plus sign in here meant you're going to the left and you know it shifted pi units, by all means, that's fine. But it just depends on what your teacher is picky or not about. The midline equation is y equals d, and d is 1. Okay, so y equals 1 is right over here. So that's going to be the midline. And then last but not least, the n value is always going to be the phase shift. So that's negative pi plus the period. So it's phase shift plus the period. So negative pi plus 2 pi will give us pi. Okay, so it starts at negative pi and it ends at pi. Okay, so it does work out, right? The period just means it completes one full cycle in 2 pi radians. You're going to take the average. What's negative pi plus pi divided by 2? So negative pi plus pi is 0, and then 0 divided by anything is 0. Okay, so you could know this by symmetry. You don't have to do the average formulas, but I'm just doing it for people who need it. So if we want to find the exact middle of those two, we're trying to find the exact middle of 0 and pi. So those are the ones that I'm going to add together and divide by 2. 0 plus pi is pi. So that means that in between here will be pi over 2. So again, by symmetry, we know this is going to be negative pi over 2. But again, for those people who need it, so we're finding the average of negative pi and 0. So those are the ones we're adding up, divided by 2. So now it's time to figure out what our range is. And again, we're going to use the amplitude and the midline together. So you're just going to start at the midline and then add and subtract the amplitude. So if the amplitude is 1, right? So this is at 1, 1 plus 1 is 2, and then 1 minus 1 is 0, right? So we're already over here. Okay, so this is a sine function. It will go up to the maximum and then down to the minimum because the a value or the leading coefficient is positive. So the sine function always starts and ends at the midline. And then halfway through, it's also at the midline. Okay, and so it's going to go up to the maximum and then down to the minimum. All right, last but not least, so I would recommend you press pause and you could try this all out yourself and then we can go over it. So the first step would be to write it in standard form, right? So this can be rewritten as y equals negative 1 cosine of half or 0.5x minus a negative, right? Because a minus minus is a plus, and then plus 0. All right, so that means that a is negative 1, b is 0.5, c would be negative pi, and d would be 0. Okay, so now that we know the a, b, c, d values, we can just pop it into the formulas. So the amplitude is the absolute value of a. So the a value was negative 1. So the absolute value of negative 1 is 1. Now in doing so, again, something should go off in your head. Hey, the a value is negative. And so this right here, again, so since a is negative or less than 0, so we know it's going to be flipped. So it's called inverted or flipped. So that means there's going to be a reflection over the midline, right? Okay, so keep that in mind. The period is 2 pi divided by 0.5. So if you are not allowed to use your calculator here, right, so it's really the absolute value of 0.5, but it's already positive. So if you're not allowed to use your calculator, which is highly, highly probable, 0.5 is the same thing as 1/2, right? So if you do keep change flip, that's 2 pi over 1, right? Because this is over 1 times the reciprocal. So that's going to be 2 over 1. And so multiplying fractions straight across, 2 pi times 2 is 4 pi. 1 times 1 is 1. So 4 pi divided by 1 is 4 pi. So instead of it completing one full cycle in 2 pi radians, now it happens in 4 pi radians. So there was that horizontal stretch, right, or expansion. Okay, the phase shift is, again, the c value divided by the b value. So c is negative pi divided by 0.5. Okay, so negative pi divided by, again, 0.5 could be written as 1/2. And when we do the keep change flip, right, negative pi really has a denominator of 1. Flip 1/2, so it becomes 2 over 1. So that becomes negative 2 pi.
Okay, so the phase shift is negative 2 pi. So honestly, that's just saying that it shifted. So really, it should just say the phase shift is it shifted to the left 2 pi units. That's really, so I'll just write left 2 pi. So that's really what it is. But negative 2 pi again, so that's just our start value. And that makes sense because if we remember from transformations, the plus really means we're going to the left, right? Okay, and the midline equation, so the midline will end up being the x-axis because d is 0. Okay, so here's y equals 0, or the x-axis. And then last but not least, we have to figure out that n value. So again, it's going to be the phase shift, which is negative 2 pi, plus the period. And the period was 4 pi. So negative 2 pi plus 4 pi is 2 pi. So that means that we end over here, right? And the distance between negative 2 pi and positive 2 pi is 4 pi. So that checks out. All right, so before, again, we start on graphing, we have to find the other critical points. So by symmetry, so you could add negative 2 pi and positive 2 pi, which is 0, and then divide by 2. Or it would just make sense that 0 is in the exact middle. And also by symmetry, that would mean that's going to be pi and that's going to be negative pi. But again, if you want to use those average formulas, knock yourself out. So we're going to figure out the range. So again, we start at the midline and then we're going to add and subtract the amplitude, which is 1. So 0 plus 1 is 1, and then 0 minus 1 is a minus 1. Okay, so the range is going to be between negative 1 and positive 1. So this is a cosine function. So usually it starts and ends at the maximum and it's a U shape. But again, since the leading coefficient is negative, now it's going to start and end at the minimum. It's a reflection over the midline. So now halfway through, it's actually going to be at that maximum point. And then the second and the fourth critical points are going to be at the midline. So it's going to end up looking like this. So again, if the leading coefficient was positive, so it would again look like here in pink. So I hope you were able to find this lesson helpful. In the description, I did leave a link, as I said in the beginning of the video. Here's a link to my website. So if you want, you can download. There's a 10-page packet with problems. There's 2 double-sided worksheets. Everything has step-by-step answer keys. There's a reference sheet. This was just a snippet of today's lesson, so you can access the full lesson with also some examples that we didn't go over together. And just make sure you hit that subscribe button so you don't miss out on future videos. And if you have any questions or if you were confused about anything, just hit the comments below.